Today we're in section 11.5. We're learning your fourth and final transformation. Okay, so yesterday you were tested over 3 out of the 4 transformations. Today is your fourth type of transformation. A dilation is a change in the size. Notice I said size, not shape. It is a change in the size of the figure. Okay, so here they just give us the example. You don't have to write this down. Anybody ever had your eyes dilated?
No.
Okay, so they make your pupil larger, okay, so they can see inside your eye and make sure that you don't have any like diseases or infections or anything in your eye. Make sure everything's healthy. Okay, to dilate your eyes means your pupils are enlarged and you're more sensitive to what? The sun. So you have to wear sunglasses until your pupils go back. You sometimes get a headache. Anybody ever got a headache? Yeah, that'll happen. Okay, so a dilation, guys, of a figure is very similar to what you're thinking. It's a change in the size. But how do I know? How it changes? Well, we'll talk about that in just a second. All right, you have a section just like you have on all of your other assignments where you're looking at 2 figures. You do not need to draw these. I basically just copied them right out of your book. All you're looking for is, does the figure change size but not shape? Okay, does it change in size but not shape? It can also, it can still rotate or flip or turn. That criteria can still be allowed. You're basically just looking for, is it a symmetric change in size? Basically like, even. All right, so on A up here at the top, the triangles that are kind of on their side, what do you think it looks like? A dilation, yes or no?
Yes.
Yeah, it's definitely a dilation because it's changing in size, not shape. On B, what do you think?
No.
It's not, okay? It's a translation, meaning that it's shifting, but it's not changing in size. And guys, on a quiz or a test, I would make this very evident. All right, so like one would be small and the other one would be clearly and visibly larger. You don't have to say, oh, did she change it by like a millimeter? I'm not going to do that, okay? All right, it's either going to be obvious or not. All right, now on number 1 on the bottom, is that a dilation?
No.
No, what is it? All right, so here's what the directions say, though. Is it a dilation? So my answer is no. But I know that it's a reflection based on what I've already learned. All right, what about number 2?
Yes.
It is yes. Now, I think on the screen it might be a little harder to see, but again, on paper, it's going to be an obvious change. All right, so again, we're just recognizing like a yes or no. On your homework, you do not have to copy the figures. All you have to do is say yes or no. All right? Okay, but here's where we really get into the important part of the lesson. There are 2 types of dilations. An enlargement, where you would multiply the ordered pairs by a scale factor, or a reduction, where you would divide by the scale factor. You also need to know that the scale factor, the variable that they use, is a k. You're going to see that on your homework. It's going to say k equals 3, or k equals 5, or k equals 1/2. That variable k stands for scale factor. I have no idea why. That's what it is. So k is your scale factor variable. All right, like I said, you're going to see that on your homework. That k value tells you what the scale factor is, okay? Now, on each one of these, I want you to write the ordered pairs and then give me some blanks below them to write your new ordered pairs. Same thing with the second problem. Write your original ordered pairs and then write some blanks below to write your new ordered pairs. We're going to do 1 enlargement and 1 reduction, kind of show you both sides of this concept. So the scale factor, all right, so here's basically just like the key here. If the scale factor is more than 1, okay, that means that you're multiplying. Actually, you're really multiplying either way. But if it's more than 1, it means that it's an enlargement. All right, so whatever the scale factor is, you are going to multiply each x and y value by that number. Okay, whatever the scale factor is. So in the first one, the scale factor is 3. So you're going to multiply each xy value by 3. So let's look at the first order pair. A is 1, 3. So let's start with the x value. What's 1 times 3? 3. And now let's do the y value. What's 3 times 3?
It's 9.
9. Okay? So let's do point B now. So for each value, I have to multiply it by my scale factor of 3. So what's 2 times 3?
6.
What's 3 times 3?
9.
All right, go ahead and do C. All right, what's point C? 6, 3. 6, 3. Multiplied each value by my scale factor. Now, I know that the second one is a reduction, okay, because my scale factor is less than 1. Because the scale factor is less than 1, I know it's a reduction. I'm making it smaller, okay? I'm taking half now of each value in the ordered pair. You see that? So half of a number makes it smaller. That would be a reduction. Or a fourth. I could take a fourth of, obviously my original ordered pairs would need to be bigger to take a fourth of it. All right? So, or a third to divide by 3. All right? So if my scale factor is less than 1, it's a reduction. All right, so let's half all of our original ordered pairs. All right, let's go with point A. What's going to be my new ordered pair for point A after a reduction of 1/2? 2, 4. Okay, go ahead and do B and C. Okay, what's B? 4, 2. And what's C?
4, 1.
And that's a reduction. Okay? So just go by the scale factor, do your new ordered pairs. On the next slide, we're going to take the second one, the one that we just did, the reduction, and I want you to put that on a graph, okay? So we're doing one graph today where I just want you to see it on a graph, what it looks like, to draw the figure and its dilation. And don't be confused by the word dilation. It could mean that the image is smaller. In this case, the image is smaller. And when you graph the image, are you supposed to use a solid or a dotted line? A dotted line for the image. So make sure you do that. Okay? Only a couple people missed that on the test, but make sure for the original figure it's a solid line, and the new figure or the image it's a dotted line. Go ahead and plot both of these triangles on your graph. Okay, does your original figure look like this?
Yes.
Okay, does your image look like this?
Yes.
All right, okay, so there you go. All right, same shape, different size, dilation. Okay, last slide. Using more than one transformation. And guys, this is open game. We literally could spend the next 20 minutes just doing these types of problems, because what I mean by open game, it could be a reflection, it could be a translation, a rotation, a dilation, any of the combination of those transformations. In this specific example, it just so happens to be a dilation and a translation. Okay? But based on our test yesterday, I think it's, pretty clear that we know how to reflect and rotate and translate. So just follow the instructions. Whatever it is, just follow the instructions first. So it's going to be some practice for dilation again, and then we're going to translate those ordered pairs also. So just read the instructions. Dilate the trapezoid using a scale factor of 2. Right there, I know what I'm doing to my x and y values. If it's more than 1, I know that it's an enlargement. If it's less than 1, I know it's a reduction, but either way, I'm multiplying by that value. Okay? So I want you to write your new A values. Let's just do A. Just do A. Okay, so for point A, what is negative 2 times 2? It is negative 4, and what is negative 1 times 2? Negative 2, okay? Do not overthink this and think, oh, well, technically I just made my x value smaller, like negative 4 is smaller value. You got to think about it. When you're graphing in the negative, you just went from a negative 2 to a negative 4. You're making the figure larger in the negative quadrant, okay? So don't overthink that. You're basically just still doubling the negative value. All right, go ahead and do B, C, and D. What is B? Tell me. Negative 2, 2. What's C?
0, 2.
What's D?
0, negative 2.
0, negative 2. Now take these 4 ordered pairs. You do not go back to the original. Take these 4 ordered pairs, and now you're going to follow the second transformation, which is a translation, 6 units right and 2 units up. So someone raise your hand and tell me, what am I doing to my x values now? Isaiah?
You're going 6 units right.
Which is what operation, though, to my x? No. What operation? Am I adding or subtracting?
Adding.
I'm adding 6. How do I know it's add, not subtract? Very good, because I'm going to the right, okay? So I need to add 6 to my x value. So what's negative 4 plus 6?
2.
Positive 2. Now what am I doing to my y value? Someone raise your hand. Tell me, what am I doing to y, Kennedy?
You're going 2 units up.
Which means, very good, I need to add 2 since it's going up. So negative 2 plus 2 is what?
0.
0. Go ahead and do B, C, and D the same way. All right, and this would be the coordinates of my image once I find all of these. Okay, what's point B?
4.
Okay, what's point C?
6, 4.
What's point D?
6, 0.
Okay, and if you were to graph this from the original trapezoid to the new trapezoid, you would see that it's getting larger by a scale factor of 2 and shifting. Okay, so maybe you can kind of visualize that on the graph. All right, so that's it, guys. That's it for 11.5. We skipped 11.4 to kind of keep our transformations together. We may go back and revisit some of the concepts from 11.4, but definitely in Chapter 11, the most important concept is these transformations and being able to change these ordered pairs. All right, so that's everything you need to know.